recording. So, alright. Got a car, 20 meters in 2 seconds, and we start at rest. Okay, if I'm making my cheat sheet for Wednesday, remember you can have one 8.5 by 11 piece of paper, anything written on it you want, which includes solved problems if you feel like you need to do it that way. But as long as it's on one half of it's only on the front sheet of the paper. So my equations that I have is I've got velocity final is equal to velocity initial plus the acceleration times time. I've got velocity final squared is equal to the velocity initial squared plus 2 times the acceleration times my change in distance. And I've got distance is equal to the velocity initial times my initial velocity plus 1/2 AT squared. You will have on the test a couple conversion problems. You will have on the test calculating a kind of like a volume or an area or something along those lines. Watch your units. And then you've got some vector problems as well as our kinematic motion problems. All right. So I know distance. Distance is 20 meters. I know time. Time is 2 seconds. I know my initial velocity. It's 0 meters per second. And I want to find acceleration. So when I look at my problems here, I don't need a final velocity, so I'm not going to use that one. I don't need a final velocity, so I'm not going to use that one. So I'm going to end up using this one. And my initial velocity is 0, so I can get rid of that term. And now I've got distance is equal to 1/2 the acceleration times time squared. Solve for acceleration. I get 2 times the distance divided by time squared is going to equal acceleration. My units are meters per second squared. And in this case, I'm going to have 2 times 20. And I'm going to divide it by 2 squared. And so those of you who put the 10 meters per second squared are correct. All righty. Let's go back. Okay. We'll do this one. The other thing about physics problems, don't make them harder than they are. You can't see the question? A ball is thrown straight down from the top of a building with an initial velocity of 10 meters per second. What is the acceleration of the ball? Choices are 0 meters per second squared, which is A. B is 4.5 meters per second squared. C is 9.8 meters per second squared. And D is 19.6 meters per second squared. I'll give you one more minute. Okay, the problem was this. We've got something happening and we're throwing the ball down at 10 meters per second. And I want to know the acceleration. I'm just going down with gravity. I haven't done anything to give me an acceleration other than gravity. So I can just write that it's 9.8 meters per second squared. It's one of the things that we know about our problems. No matter whether I'm doing this, I'm doing this, I'm doing this, as long as I'm on Earth, the acceleration due to gravity is going to be going down, and it's going to be 9.8 meters per second squared. Now, if I'm on the moon, it's going to be something different. If I'm on Jupiter, it's going to be something different. But no matter, as long as I'm sitting here on Earth, it's going to be 9.8 meters per second squared. And it's something that I know about the situation for kinematics. Okay, next. Okay, we'll do this one. All right, this one is we've got a bullet fired at an angle of 30 degrees, has an initial velocity of 92 meters per second. What is the acceleration of the bullet in the x direction? And my choices are 0 meters per second squared, 9.8 meters per second squared, 19.6 meters per second squared, or none of the above. I'll give you guys another minute to do it. Okay. .92 meters per second. All right. So we're given that we've got a bullet And I'm going to draw my little Dr. Seussian bullet here. And we're told that the bullet's going to go off with an initial velocity of 92 meters per second. And we're told that this angle is 30 degrees. Things we know. We know the velocity at the top is equal to 0 meters per second. We know we have an acceleration due to gravity, but it's in the y direction, and it's 9.8 meters per second squared. We know that x and y are independent. And if I were writing out my cheat sheet and I'm going into the end of the third chapter, I've got x is equal to my velocity in the x direction times time. I've got y is equal to my initial velocity in the y direction times time minus 1/2 gravity times time squared. I've got the velocity y final is equal to my initial velocity y squared minus 2g times the change in height. And I've got velocity y is equal to velocity y minus gt. So what's my acceleration in the x direction? Because I have an independent variable. So my acceleration in the x direction when I'm doing projectile motion, and once it leaves the object with which it was causing the motion, it's going to be 0. It's going to be 0. So, other things I might ask you on an exam are, how far downfield did it go? Well, the thing I need to know in order to figure out how far downfield it went is I need to know time. So that's one issue I might have to calculate. I'll need to know the velocity in the x direction. I'll need to know the velocity in the y direction. My velocity in the x direction is going to be my 92 meters per second times the cosine of 30 degrees. And in the y direction, it's going to be 92 meters per second sine 30 degrees. And if I plug those into the calculator, that gives me 79.67 meters per second for the x direction. And it gives me 46 meters per second in the y direction. So that's my x direction, my y direction. How I would calculate the time is I would use this equation right here, because I know the velocity at the top has got to be 0. I know what my initial velocity in the y direction has got to be. And this time that I calculate doing that is 1/2 the time of flight for this situation. So I can use what I know to get the other information that I need in order to solve where I'm headed. So if I really want to solve distance, so in this case I'm going to have my 46 meters per second is equal to gravity times time. So it's going to be 46 divided by 9.8 meters per second squared. That's going to give me my time. I do 46 divided by 9.8. It gives me 4.69 seconds. Now I can put my 79.6 meters per second times my 4.69 seconds. And it's going to land 373.96 meters downrange. All right, ready for the next one? Okay. We'll do one a little simpler here. Okay, we've got a ball thrown straight up. For which situation is the vertical velocity 0? On the way up, on the way down, at the top, or none of the above? Give you about half a second or half of a minute to answer. Hopefully you all got that it was at the top. Because if I'm tossing the ball, that's when my velocity changing from positive to negative, and so that is at the top. All right, let's do another one. Oh, this is a good one. Okay, we've got a ball that's rolled horizontally off the table with an initial speed of 0.27 meters per second. A stopwatch measures the ball's trajectory time from the table to the floor to be 0.3 seconds. What is the height of the table? 0.44 meters, 0.45 meters, 0.52 meters, 0.012 meters, or 0.36 meters. So the best approach to these problems, whether you're doing it on a test or doing it as your homework or doing it, is to first draw your picture so you have a clear idea of what is happening. So you want to draw your picture, write down your equations that you need. Look for what you know and look for what you don't know. So we got a ball that's rolling horizontally off the edge of the table. 0.27 meters per second is the speed. We measure the trajectory time at 0.3 seconds. What's the height of the table? And my choices are 0.44, 0.45, 0.52, 0.012, 0.36. And this should look really much like the lab that you guys have done in the past week. right, I'm going to give you about another minute. Okay, so the situation we have is this. We've got a ball. It's going to come off the edge of the table. We're told that the time is 0.3 seconds. We're told that my initial velocity was 0.27 seconds. And we want to find h. So if I go back to my equations, I got my distance is equal to my initial velocity in the x direction times time. And that's that distance right there. I have that my y velocity is going to equal my initial y velocity minus gravity times time. I have my y velocity final squared is equal to my initial y velocity squared minus 2g times my height. Well, this one at least has the variable that we're looking for in it. Then I have my height is equal to my initial velocity in the y direction times time minus g over 2 times time squared. I don't have an initial velocity in the y direction because it's coming off the table horizontally. And I'm told that my time of flight is 0.3 seconds. So I get 2h divided by 0.3 squared. Oops, I don't want to do that way, sorry. I'm just going to plug in the numbers. I'm going to have two negatives, so that becomes positive, so I get 9.8 times my 0.3 squared divided by 2. And when I plugged that in the calculator, I got 0.441 meters. And if you double check your units, I've got gravity at meters per second squared times second squared. Second squares cancel, and I end up with meters, so I know I've got my units straight. Yeah?
Why does the h become negative?
Because I'm starting here, and I'm going down, and if I use g as the same one, I have to have the same direction. Now, I could have left it positive and have a measuring h in the same direction, but usually if I'm doing it below grade, I would use the negative. Now, the only difference in your lab that you guys did, this is exactly what you did in your lab, except in my lab, I had a timer gate here and I had a timer gate here, and the distance here was 0.1 meters, or thereabouts, right? Some of you may have had a little different number, but it was 10 centimeters between the two gates. And you measured the time that it took to go through there. So let's say that time was 0.36 seconds. You had to calculate the velocity. My velocity is equal to the change in position with respect to the change in time. So in this case, it would have been 0.1 meters divided by 0.36 seconds. And if I did that, that says, take a guess, 2.8 meters per second. And I just pulled those numbers out of my hat. So this is probably very similar to what you actually did in lab. And you did it like 5 times. And once you got the velocity, you made a prediction as to where that was going to land. So let's look at where it would land. The distance is going to equal my initial velocity, and we'll use the one that was in the problem, 0.27 meters per second, times my 0.3 seconds. And if I do that, that's 0.081 meters. So my target would have been 0.081 meters. Okay. Let's see what else I got. And save this other one for last. We're going to do this one. So we've got a driver puts on the brakes and decelerates from 30 meters per second to 0 in 11 seconds. How far, or what's the distance the car traveled? I will tell you it's a two-part problem. And the answers that are provided are 165 meters, 124 meters, 206 meters, 248 meters, and 83 meters. Okay, we ready? We got two predominant answers here. Let's look at the situation. It's actually a practical situation. 30 meters per second is about 70 miles an hour. And we've had all this, most of us have had this happen to us. We've seen a deer out there and we hit the brakes, right? So we're going to do a deceleration. That is not an uncommon deceleration time. 11 seconds. Braking time. Particularly if you're traveling on a wet road. So we got a problem, right? We got an issue here. So the first thing I want to do is I want to calculate the acceleration. Because I got to know it. Now when it's negative, it's a deceleration. So I've got an I've got a final velocity, I have an initial velocity, I have an acceleration, and I have time. So that's the equation I'm going to use to start the calculation, because I got to have that acceleration. Because I also know that my distance is going to equal my initial velocity times time plus my acceleration divided by 2 times squared. But I got to have that value in order to use my distance equation. Okay? Got to have that value. I also have another equation at my disposal. But I don't have the distance and I don't have the acceleration, so that I'm not going to be able to use that one. All right? So, my final velocity is equal to 0. This is equal to my initial velocity. So I've got final velocity minus my initial velocity is equal to my acceleration times time. I have final velocity minus my initial velocity divided by time is going to equal my acceleration. And so if I put those numbers in, I have 0 minus 30 meters per second divided by 11 seconds. Gives me the right units, meters per second squared. And when I plugged it into the calculator, I got a negative 2.73 meters per second squared. Now my distance is going to equal my initial velocity, which is 30 meters per second. My time is 11 seconds. Plus, now I've figured out my acceleration, which is a negative 2.73 meters per second squared, divided by 2 times my time of 11 seconds squared. When I plug that into the calculator, I got 165 meters. Everybody follow what I was doing. Yeah, it's a two-part problem. I have to figure out my acceleration first, then I can figure out the distance.
I think the hardest part for me is just remembering the formulas.
And for you guys, remember, on the test, you can have your cheat sheet. And you remember the formulas just because you work with them so many different times. You're writing them out. Okay, last one. This is a vector problem. I saved it for last. Okay, we've got a dog running 520 meters. It's a good sheepdog. Okay, got a good sheepdog. Runs 520 meters at 20 degrees north of east for 30 seconds. Then runs 380 meters at 55 degrees north of west for 20 seconds and stops. What's the average velocity of the dog? I'm going to do it this way because that way everybody can see the problem a little better. Or at least the answer is a little better. So we've got running 520 meters north of east. Then turns and runs 380 meters at 55 degrees north of west for 20 seconds. What's the average velocity of the dog? Now, test taking tips. for Wednesday, you do not have to do the questions in order. So my first comment would be to read the questions, answer the ones that you can knock out right away, get those done. Because you might have a problem that looks just like this, and you can see that this takes a little bit more time. You want to save your time-consuming problems towards the last. And because it is multiple choice, you at least got 1 in 4 or 1 in 5 shot of getting the answer towards the end. You know, at least fill in the blanks because there's no penalty for the wrong answer. So leaving it blank is just as wrong as you might get a 1 in 4 chance or a 1 in 5 chance of getting it right. So you might get yourself some Benny points. But do the easy ones first. Then do the ones that are more time-consuming ones, and tackle the ones that you have no clue last. I'll give you a couple more minutes to do this one, and then we'll work it out. Okie dokie. So this is basically the situation that we have. The dog ran 520 meters, 20 degrees north of east. Okay, so if you do your north, south, east, and west, that's my 20 degrees north of east. Then the dog turns and runs 380 meters, 55 degrees north of west. This is the resultant vector. So that's the vector I have to find in order to calculate the average velocity. So the way I did it is I said, all right, this vector here, so this is vector 1. Vectors have direction and magnitude. I'm going to do my 520 cosine of 20 degrees. That's in the I direction. 520 sine of 20 degrees in the J direction. That's in my X direction and my Y direction. So vector 1 can be written as 488 I plus 520 J. This vector, vector 2, is going to be negative because I'm going in this direction in the X direction, 380 cosine of 55 degrees, plus 380 sine 55 degrees. And that's in the J. When I write vector 2 out and I plug it into the calculator, I get a negative 218 in the I direction plus 311 in the J direction. So everybody's, yeah.
We got 488.
520 times the cosine of 20 degrees. Yeah, so basically what I did is I broke it up into its two components. So I broke it up into its two components. And then I wrote it in vector form. So now I have the two vectors. So I have vector 1, and that's 488I plus 5. Whoops, sorry. I didn't write it down right. Sorry. That's 178. I didn't do the calculation on my pepper. I have it over here, but I didn't do it over here. I was going, wait a second, that's the same length. So it's 178J. And that's why I say show your work. Because you know what? That only is going to cost you 1 point if you show your work. Now, it'll cost you the wrong answer on the little Scantron, but I will give partial credit. So if you come back and you've got this all written out, and I see that you've only written that you did exactly what I did, I'm only going to take off a point. I'm going to give you 4 out of 5 points if it's a 20-point test for getting that far. So, I mean, really, show me your work because I will give you partial credit. You don't show me your work, I can't do it at all. So this is going to be minus 218I plus 311J. 488 minus 218 works out to be 270. 178 plus 311 is 489. And basically what I now have is I have a triangle that looks like this, that I'm 270 here and I'm 488 here. I want to know the length of the hypotenuse. A squared plus B squared equals C squared. So the square root of A squared plus B squared ends up being the magnitude of my resulting vector. So I'm going to take my 489 squared plus 270 squared, take the square root of all of that, and that gives me 558, and that's in meters. It took 30 seconds to do this leg. It took 20 seconds to do that leg. The velocity is the change in position with respect to the change in time. So that's my 558 meters divided by my 50 seconds. And that gives me 11.2 meters per second. And if you went through and carried it with this 520 and got a different answer, I'm only going to take off a point. Because you've got the whole methodology right. Just had an arithmetic error. But you have to show me your work in order to get those partial credit points. Okay, test is on Wednesday. 8.5 by 11 sheet of paper. If you send me a question over the weekend, I will try to respond to those questions on Monday so that I will respond to them before the test. The more complex projectile motion problems are due like 10 o'clock on Tuesday night so that you guys can see the solutions in WebAssign. And if you are still not being able to access your book, I would contact IT. Yep, front side of the page.